On to mass. The mass of an object is the measure of the amount of matter in the object. The weight of an object is the measure of the gravitational pull on an object. It's how much gravity is pulling on it. So a person who weighs 150 pounds on Earth would weigh about 25 pounds on the Moon. However, their mass would be about 68 kilograms both on the Earth and the Moon. Now, as long as we're only talking about things that are on Earth, we can treat mass and weight as the same. The base unit of mass is the kilogram, and this really bugs me because the base unit, kilogram, is not the root word, gram. So don't let that confuse you. The base unit is kilogram. There are grams out there, but that's not the base unit. That's just the root word. Looking at a table, we do have a new unit, the ton, or the metric ton. And since we have the root word, this will be the root word, this is our base unit. A ton is 1,000,000 grams, or it's 1,000 kilograms, or kilogram, and that's about the weight, the mass of a full-size automobile. A kilogram is 1,000 grams, which is about 2.5 pounds, 2.2 I mean. A hectogram, which would be 100 grams, or a tenth of a kilogram, that's rarely used. Same goes for a decagram, which would be 10 grams. Deca means 10 of the base word. That's 10 grams, but it's 100th of a kilogram. That's about the size of 2 nickels, but we don't really use it anymore. Or I don't know that they ever did. We don't really use it. A gram is 1,000th of a kilogram, and that's the average daily requirement of calcium. It's pretty light. Decigram, a tenth of a gram. Centigram, 100th of a gram. Those aren't used much. We do use milligrams. That's 1,000th of a gram, or 1,000,000th of a kilogram. And these are used for measuring drugs and other trace amounts. You'll see some of your average daily recommended daily intake of certain metals and such in milligrams or in grams. As with the others, we have a few units that are used, and the rest of them aren't really used a lot. We stick with milligrams, grams, kilograms, and tons. Now let's remember from last section that 1 cubic centimeter is 1 milliliter. Now let's add that 1 milliliter of water is weighs or has a mass of 1 gram, or 1 gram of water has the volume of 1 milliliter. So that gives us a nice clean definition, a nice clean conversion between these different units. Now this also means that a cubic decimeter, it'd be 1,000 times the centimeter cubed. So that's 1,000 times a milliliter, which would be 1 liter. And that's 1,000 times a gram, so that would be 1 kilogram. And if you wanted to go again, a cubic meter is going to be 1,000 liters, or a ton of water. So which of these units would you use to figure out the mass of a child? Well, anyone who has been to a doctor knows that oftentimes we use kilograms, even here. A baseball, well, that's pretty light. You might say it's a kilogram, but I think it's a lot lighter than that. Probably grams. An elephant, oh, that's easy, that's a ton. And finally, a mosquito. I bring that one in because I've been told that a mosquito weighs approximately 1 milligram. Temperature. The unit of temperature in SI is degrees Celsius. Now again, they took something and based the scale on something that actually makes sense. They took the freezing temperature of water, 0 degrees Celsius, and they took the boiling temperature of water and they called that 100 degrees Celsius, and they made 100 divisions between these numbers. So we can convert between Fahrenheit and degrees Celsius. We have the following formulas. Fahrenheit is going to be 9/5 of whatever your centigrade Celsius is, and then you'll add 32 to that number. To convert from Fahrenheit to Celsius, we'll take Fahrenheit minus 32 degrees, and then we'll multiply that by 5/9. So let's look at this table. A very cold day would be 0 degrees Fahrenheit. And if we use our conversion formula, Celsius equals 5/9 Fahrenheit minus 32. So we'll take 0 minus 32, that gives us negative 32, multiply it by 5/9, and we get that's about negative 18 degrees Celsius. All right, freezing point of water, 0 degrees Celsius. Now we know the freezing point of water, but I'll go ahead and write our formula. We'll take 9/5 of our Celsius temperature and then add 32 degrees to that. 9/5 of 0 is 0. Add 32. We get 32. I'll just put that one up there. Alright. A warm winter day. Warm winter day would be 50 degrees. That would be a nice day in the winter. If we take 50 degrees and subtract 32, that would be 18. Multiply 18 by 5/9, and we get 10 degrees Celsius. A mild spring day would be 20 degrees Celsius. I wonder what that is in Fahrenheit. Well, we take 9/5 of 20, add 32, and we get 68 degrees. Now I'm starting to notice a pattern here, and that is that 10 degrees Celsius, an increase of 10 degrees is about the same as an increase of 18 degrees Fahrenheit. So, a mild spring day is 68, a warm summer day would be 86. Again, we've jumped 18 degrees here, so this must be 30 degrees Celsius. A couple of other temperatures that might be interesting to have an idea of what they are in metric. 37 degrees Celsius is body temperature. Boiling point of water, we already know that's 100 degrees, or 212 Fahrenheit. And one of the things that I think would confuse me the most if we ever convert over to metrics, oven temperature for baking, we're used to 350 Fahrenheit. That is actually about 177 degrees Celsius.